Hi, I'm Lee Teschler with Machine Design Magazine. We're here with Harry Scholl from Cyclone Power Technologies. He's going to tell us a little bit about the heat regenerative engine he's invented. So Harry, tell us a little bit about the principle of operation of the waste heat engine.
Our waste heat engine can operate off of any other heat source. It's a low temperature, low pressure engine as opposed to the regular Cyclone, which is a real high efficiency, high temperature, high pressure engine. Even there's a small engine over here which is one of our waste heat engines that actually operates on the waste heat from one of the larger Cyclones. And you can take the waste heat engine and fuel fire it and even generate electricity without the main engine running. This is the larger, little bit larger than the waste heat that operates on the truck. This one will put up to maximum 20 horsepower, which is about 12 kW, that you could have in the garage of your house, connected with special solar panels to drive electricity. When the sun isn't shining, you can burn any other type of fuel to charge the electricity, which would be any other fuel source, natural gas, propane, fuel of some sort, gasoline, diesel, or any other fuel mixture thereof, and have a very, very simple operation. Or in incinerated fuel, any trash, garbage, or anything else can power this system here, can generate your electricity for another source, because it runs off of waste heat.
Pistons are in a radial configuration. Can you tell us a little bit about why that's so?
Yeah, it's an automatic engine. It's an automatic engine. You put pressure on it, and the more pressure you put, the more the power output. As the power output wanes, if you're connected to a solar, it might slow down, because you can power back to the grid. Well, in Florida, we have more people die from generator carbon monoxide than we do from hurricanes. Well, in this case, being an external combustion, you have a minimum of gases, nitrous oxide, carbon monoxide, and those chemicals, as we do in our high pressure Cyclone engine. But this would, if you're running it off the other combustibles, you would have low noxious fumes, or otherwise in sunlight you would have none at all. See, so the higher the sunlight factor, you'd be charging back to the grid or using the power.
Why is it called an external combustion engine?
It doesn't explode in the cylinders. It burns fuel in a round donut-shaped centrifuge around the outside of the cylinders, as in these red domed engines here. The fuel is burned in a centrifuge. So it has enough time frame to burn all of the fuel, and then it goes through a series of heat exchangers, and the final exhaust temperature on these engines is only 350 degrees. And like I said, this engine here can actually run off the last exhaust temperature of this engine here. Or it can run off the exhaust temperature of an internal combustion engine that's even a higher heat loss, which is about 1,000 degrees on an internal combustion engine.
So pressure controls the speed of the engine?
Pressure and temperature. Temperature would control the efficiency, the speed would be the rate of pressure. It's all automatic. As you see, you add pressure and it goes. Okay? And as the pressure would slow down, the engine would slow down. This doesn't have a combustion cycle. You would generate the heat at another source. And then all it does is you see these tubes here where it puts pressure into the system. And the pressure just pushes the pistons down, and there's a special valve mechanism that we have that allows it to be automatic. You can even run the lower cooling section of this engine here is the same as the heat exchangers that we have in the high pressure Cyclone engine. So there's a very close similarity, but this is designed at low temperatures and low pressures, where the supercritical Cyclone is designed to operate high pressures and high temperatures and extremely high efficiencies.
Can you tell us a little bit about some applications you've got in mind?
Generating electricity is the most use from waste heat. The other, the supercritical engines, of course, are good for other generators and mobile application, anything from trucks to small ships, boats, military applications, which is a huge interest. Everything from lawnmowers. You'll see a lawnmower on the market in about a year or 18 months. That's getting into its final design stages now and going to testing shortly.
So what's the efficiency of an engine like this?
This one is about half of those, but it's very difficult to gauge the efficiency. The efficiency depends on how hot of the steam that you run in the system. You know, if it's lower temperatures and pressures, the efficiency is not as high as you keep increasing the temperature and efficiency.
So the engine that you've got in mind for a lawnmower, what's its efficiency?
It's probably a little bit better than a gasoline engine. These engines over here run up between a gas and in the low side of the diesels. However, they have a much higher well-to-wheel efficiency. They don't drive a transmission, and their efficiency is not a spike. It's nearly a straight line from the time it starts to the maximum RPM. So the overall efficiency is higher than either one if you take it in a straight line across the line. And of course, this one here is highly efficient because it runs on free fuel. Everything is wasted, from sunlight to burning trash.
How does the lawnmower engine actually work?
That one, the little lawnmower is designed to run on propane. The little tanks you can buy at your local grocery store. Plug them in, the engine is totally silent. You don't have supersonic exhaust coming out of it because it's a closed loop system. Never needs oil changes because it doesn't have oil, it's all water lubricated. You know, you don't have to run with the 5-gallon cans to the local gas station and carrying them in the back of your car. You buy these little containers in a 6-pack.